This is lesson 1 from chapter 14 on geometric sequences. Now I always include this as my warm-up question for this section. I know a lot of students in ACE go ahead and miss 8th grade math, so they lose a lot of the work on percentages. So often people actually really struggle on this question. So you might want to pause the video and try answering the questions for this. Now what a lot of people do for the first one is they simply find 25% of 20,000, subtract it. Find 25% of 20,000, which is 5,000, and that's how much the value was lost. Now when it comes to how much does it lose in 4 years, what you certainly don't want to do is say it's 5,000 for 1 year and then times it by 4. The reason being is the car's only worth 15,000 after 1 year, so the car's value changes each year, therefore its depreciation changes each year too. What you also don't really want to do is then find 25% of 15,000, subtract it, and then keep doing that 2 more times so you've got to 4 years. So actually for the first question, the way we really want to answer that question is, and I'm actually going to scroll down because I actually have some answers here, is to do this. We want to actually find what is 25% of 20,000. So we just change it literally into a decimal. Now we could actually answer that question by finding out how much the car is worth, and sometimes that's a better way of doing this question. So we start with 100%, if we subtract 25% we get 75%, so change it to a decimal, and then we have the answer $15,000. So if the car is worth $15,000 and it was worth 20,000, then we must have lost $5,000. Now when we come to the second question then, how much does it lose in 4 years? The advantage of using this method is, I can say I start with 20,000, I want to find how much it loses in the first year, but also to find how much it loses in the second year, it's the same ratio, and the same for the third year, and the same for the fourth year. Now as we multiply this together 4 times, because it was 4 years, then what I can do for this question is say that. Now if I work that out, that tells me how much the car is worth, and then once again I can figure out how much it actually lost. So if I reverse engineer this question, the answer for this would have been 6,328. So if I subtract that from 20,000, then I get 13,672. What is the car's value after 5 years? 20,000 times 0.75 to the power of 5. Probably not the most realistic example. Certainly cars do lose a lot of value in the very first year, but it tends to not be quite as much in subsequent years. So a very quick way for finding questions out, particularly if it was a question like how much is it something worth in 30 years, you wouldn't want to have to keep doing repeated subtraction. Now that links into our question on savings, because this is actually something that's increasing in value or appreciating. The APR is the annual percentage rate, so annual means it happens each year. So how much is in the account at the end of this time? So I start with 3,000. Now I want to find out what the ratio is for this question, so I start with 100%, but I also get an additional 5%, because obviously we're gaining money if we're putting it into a bank, so that's 105%, or we could say 1.05, and then just do that to the power of 3. If the question was to ask us how much interest do we get, then I'd still do the same calculation, but I'd subtract the 3,000 I started with to find out what I get left with. Just as you can see there. Now we have another question we can look at as well. And this is obviously quite an important question for a lot of people who will be going to college, and how you save for that, or subsequently when you become parents yourself. How much money should you put into an account so you would have a certain amount by a certain age when they go to college? Now this is actually a question that we can't quite answer yet, but we will be answering this before we finish this chapter. So once again, this is our first lesson, and just a reminder from Algebra 2, a geometric sequence is one where each subsequent term is found by multiplying the previous term by a constant, which we're going to call r, for ratio. And that's actually what those 2 previous questions actually were. So if I give some simple numbers, most people can tell that's geometric straight away, because you can see you're times it by 10 here. If it's not obvious you're times it by 10, second term divided by first term will tell you the ratio. And that should be true for every single term. 200 divided by 20 is 10, 2000 divided by 200 is 10. Once again, the first term we're going to refer to as A. Now there are some formulas for this section, and these are on your formula sheet. Now, the one that's not on your formula sheet is actually this one. Now, I use the questions for the formulas for the sum to n terms in different ways. If I know that the ratio is between -1 and 1, then I would use this formula. And if I know that the ratio is going to be greater than 1, I would use this second formula. Just to make things stay positive and to make your calculations a little nicer. Now, the third formula we're not going to use in the first lesson, but we are going to use in the second lesson. So the sum to infinity is a divided by 1 minus r, provided the absolute value, or the modulus of the ratio, is less than 1. If it's not, then this formula doesn't make any sense anyway, because we have a sequence that is increasing in value. And if we were to add an infinite number of things that are increasing, we would end up with infinity. So let's look at a few questions from here. So how many terms are in the following sequence? From the information we're given, we can certainly find a. We can find the ratio as well, 10 divided by 5. And we can see what the last term is. So the formula for the last term is ar to the n minus 1. And we can write ourselves an equation to show that. Now, if we start to solve that equation, divide by 5, then actually we don't have a way for actually solving that equation quite yet in ACE. And we would have to guess on the calculator what the correct answer is. 2 to the power of 10 turns out to be 1024, so n would be 11, because 11 minus 1 gives us 10. Now, there is something you did actually do at the end of Algebra 2 that would actually help you to answer that question, and it's going to be covered in, I believe it's the 3rd chapter of ACE 2. So I'm going to show you that now. When you have an equation where the variable is the exponent, then you can solve this by using logs. Now, there's two choices for logs. We can use the log button, or we can use the natural log button, which is the ln part. I choose to write the ln just because it's quicker to write than log, but that's not particularly a good reason. Now, the reason we take logs is there was 3 rules of logs that we also learned in Algebra 1. One of them was, if we have the log of something raised to a power, we can bring the power to the front. Now, that's important for us because now we can actually solve this equation in terms of n. So if we divide both sides by the ln of 2, then go ahead and add 1, you'll find that n is 11, just like we found earlier, but without the need to guess. You can also try by doing logs here. If you do the log of 1024 divided by log of 2, you will also find that you get the same answer. Now, a slightly longer question. The 3rd term of a geometric sequence is 12, and the 6th term of the same sequence is 96. What is the sum of the first 10 terms? Now, to find the sum for the first 10 terms, we know n is 10. What we don't know is a, and we don't know r, so we're going to have to try and find that. And we're going to do it in a very similar way to what we did when we did arithmetic sequences. We have 2 pieces of information here, so we can write ourselves 2 equations with 2 unknowns, and then we can solve that system of equations. Oops. So, we know that arn minus 1 is a specific term, so for 3rd term, 3 minus 1 gives us 2, and we know that the 3rd term is 12. And similarly for the 6th term, 6 minus 1 is 5, so ar to the 5 equals 96. Now, if I divide these 2 equations, then actually I eliminate the a's. R to the 5th divided by r to the 2, 5 take away 2 is 3, so r cubed equals 8, and then r equals 2. So just a very clever way of solving that system of equations. Once we've got that, we can then plug back in to find out what a is. So if we do it on this one here, r cubed was 8r was 2. So 2 squared is 4, so a times 4 is 12, therefore a must be 3. And once we've got 3, we can use our formula for the sum to n terms, a over r to the n minus 1 over 1 minus r. I chose to use that formula because the ratio was 2, so it was greater than 1. And then if you plug that into there, you should end up with 3069. Having seen those examples, you should probably have a try now on the following questions from the book. 9 sometimes turns out to be quite difficult because it involves algebra and a bit of a proof as well. But have a look at those questions. I recommend you only do A, C, E, G and I where appropriate, so just half the questions when there's multi-step problems.